Okay, this is section 12.5. We're going to be looking at the transformational form or standard form of all the conic sections, where we're moving the center from the origin to another location, and we're going to be graphing those and identifying them based off of the information that's given to us. So the first thing here is we want to write an equation of a parabola whose vertex is at 3, 2, and whose focus is at 4, 2. Okay? You want to draw the graph, identify the focus, and the directrix as a dotted line. So one of the things we can do is just put a dot and kind of start graphing this thing out and seeing where we're at. If the vertex is at 3, 2 and the focus is at 4, 2, we can see that the graph is going to be moving right or left. Okay? So when we set this thing up, we also know that the directrix is the same distance from the vertex that the focus is, just in the opposite direction. So this allows me to find that value of P from that. And so I'm going to go ahead and start drawing something out over here. Right about here. So I know I have a vertex at 3, 2. I have a focus at 4, 2. And so since that distance is 1, I know the directrix is 1 unit behind the vertex. So I know that this is the directrix right here, indicating then that the graph, the parabola has to open to the right. So this is x equals 2. Okay, and we can find some values and plug it in and all that stuff, but we have to find the equation first. So we have one that goes horizontal. That means the y is squared. So we have our generic formula, y minus k squared is 4 p x minus h. H and k are the vertex, and p is the distance from the vertex to the focus. That is a distance of 1 unit, meaning that p is going to be 1. So based off of what we see, we know p is 1, and we know that h and k is 3 and 2, and so we can just plug our numbers right into this equation. Y minus 2 squared, 4 times 1, so that's 4, x minus 3. So there it is, there's my equation. And we can actually use this equation to find some more of the values and such. We know that the vertex is at 3, 2, and so we can come here, we know it's going to go to the right. Let's see what happens at 4. I don't know, if I plug in 4, what am I going to get? Okay, I plug in 4 over here, then I get y minus 2 squared equals 4 times 1, or just 4. So y minus 2 is plus or minus the square root of 4, or plus or minus 2. And so y equals plus or minus 2 plus 2, which means I'm going to have an answer of 2 plus 2, which is 4. And I'm going to have another one, which is negative 2 plus 2, which is 0. So at 4, I know I have a dot here at 0, and I have another dot here at 4. And so that gives me kind of some width about this, and we can draw our parabola accordingly. Label everything. So this right here is the point 4, 2. This is the vertex at 3, 2. And the directrix is labeled, and there you go. There is our parabola. At the bottom here, we have this equation right here. And we look at it, and we see that there's going to be 2 squares, an x and a y that are squared. We see that there is the same numbers in front. The leading coefficients will be the same number, so we can see that this is clearly going to be a circle. This is a circle centered at 1, 4. And if you don't know how I'm getting this, just remember what makes that 0 is a 1. What makes that 0 is a 4. And then the radius is the square root of that number right there. So the radius is the square root of 9, which is 3. And then I can take that and I can graph this over here. So we have a center at 1, 4. We have a radius of 3, so I can use my compass a little bit high, but I can use my compass. Oops, I'm in the wrong spot. It's 1, 4. And then I can do this out as a distance of 3 units from here. So 1, 2, 3. And then I can draw the circle. Again, I should have lowered it a little bit, but you get the idea. So there it is. Here's my center at 1, 4. Okay, and the radius is a distance of 3. Okay, let's look at some other questions. So here is an ellipse. They want us to write the equation of the ellipse and graph that and label all the key values. So same thing again, it's beneficial when you first start out, before you start trying to write the equation, is to draw a little quick sketch of these things just to see if it's going to be a horizontal or vertical. You already know it's an ellipse, and depending on which one we have, horizontal or vertical, will kind of determine the makeup of our equation. And so remember, well, let's just go ahead and do that. Let's graph some of these points and see what we have. So again, going to draw some little things over here. Since we're going from 4 and stuff like that, so positive 4 is going to be more onto the side, so I'm going to move this over just a bit. And you can see from our values that I don't have enough room to go by ones, so I'm going to have to go by 2s on my scale. So this would be a 2, 4, 6, and 8 that way. -2, -4, -6, -8, and so forth and so on. Okay, so let's put some dots where these things are. I have the foci are at 4, 2. So I have a foci here and another one here. I got vertices at 4, 4 and at 4, -8. So we can see that this is going to be the major axis right here. So it is going in a vertical direction. And since it's going in a vertical direction for an ellipse, okay, that means the A value has to be, the bigger number has to be under the Y. Okay, so a lot of times I just put the Y values first that are bigger. So we have a Y minus A squared and over A squared, and then an X minus H squared over B squared equals 1. Okay, and so we need to find our H and K, which would be the center of this. And the center is literally in the center. So whether it's halfway between the foci, right here in the middle, so we can see that our center is going to be the point 4, -2. And we can determine the A value by simply looking at this and seeing that from here to here is a distance of 6. Remember, this is the vertex, this is the center, and A is the long distance. So that is 6. We can also find C. Okay. C is the distance from the center to the foci. And so that is a distance of 4. And then from that, we can go over here and find B, because C squared is A squared minus B squared in an ellipse. And plugging these numbers in and solving it out. And we get, this will be 16, 36, B squared. So B squared is 20. And so now I have everything I need. I can now plug it into my equation over here. We have Y minus a -2 squared, okay, over A squared, which would be 36. And then X minus 4 squared over 20 equals 1. So there's my equation. And then over here, we're going to find our ellipse. And so the distance in the minor axis is going to be a distance of the square root of 20. And you can evaluate that out to get an approximate value there. So b is plus or minus the square root of 20, which is 4 times 5, so plus or minus 2 the square root of 5. And you can use a calculator if you need to figure that out to get an approximate decimal value. So what is the square root of 20? And you're going to get 4 points, so this is approximately 4.47. Okay, so from here we're going to go basically 4.5, so 2, 4, and a little bit. So right there, and then 4.5 basically this way puts me right about there. And so those are the minor axes right there in that distance. So we draw our parabola, our ellipse. So as best you can, and then labels things. So we know our center is at 4, -2. This is at 4, -6, 4, -8, 4, 2, 4, 4. And this over here is 4 plus that. So this is at 8.47, -2. And then 4 minus that. So this over here would be a -0.47 at -2. So that gives you those values right there. Okay. Down here below, I look at this and I want to know, okay, what kind of graph is that going to be? I see that both of them are squared, but I also see that one of them is negative. As soon as one of the squares is negative, this is a hyperbola. Okay. If they were both negative, then we can probably do some kind of manipulation and move things around, and maybe it'll work out that it would be multiplying both sides by a -1 might make everything positive. But we have to look at a situation like that. We want to draw this graph, label the asymptotes as dotted lines, label the vertices and the foci and all that good fun stuff. So what do I know? Based off of this, we know there's a number underneath here. Since there is none written, we know it's a 1. Okay. We know since the y is the negative, since y is negative, x is positive. So because of that, which one is positive, that's the orientation. So since x is positive, it is going to be going in a side to side. So left and right is where they're going to open up. Okay. So that's important. That means this number right here is A, and that number is B. So again, here's my generic horizontal equation. Okay. And so we can use this information then to help me find everything that I need. So A in this case is going to be a 1, and B is going to be a 4. Okay. We have the center of my hyperbola is going to be at 5, -2. Okay. And so from that, we can come over here and we're going to start drawing this out. So I'm going to put it right here. And a little bit up here. And I'm going to have to go by twos again because the numbers are just pretty large. So 2, 4, 6, 8, 10, and -2. Okay, so our center is at 5, -2. So 5, -2 right there. That's my center. Okay. 1 is the distance side to side. It's 1 unit over from the 5. So I have a dot here and a dot here. And then for 4, I need to go 4 up from here. So that'd be 2 and 4. So there's a dot there. And then down to this way. And I needed that because this is the box. try to draw the little rectangle that's in there based off of A and B. And then from this, we need to draw the diagonals, which are the asymptotes, from here through the center, through this point down here. Draw them as dotted lines. And then we do this one. Okay. And so there's my asymptotes for this. And so we need to be able to, we got to find C, because we want to find the foci too. So in this case, we know that C squared is A squared plus B squared. So we plug in the numbers for A and B. I'll get 1 and 16. That's 17. So C is plus or minus the square root of 17. And you can use a calculator, and this will approximate it out to about 4.1. Okay. So from the center, okay, that right there on the box, right there, that is the vertex. 1 unit from the center. Okay. The foci is this many units. Okay. And so that means it's going to put us from the center. We add 4 to the center, and that's at 5. So 4 right there is going to be 9.1. So basically right there. And then go subtract 4 from that, and you're going to be over here, right about there. Okay. Once I have the asymptotes and the vertex labeled, I can draw my shape. You can try and plug in more numbers if you want, but basically what it's going to do is it's going to go this way, and it's going to hug that dotted line. And then it's going to come this way, it's going to hug this dotted line. And then this one down here. So that is the hyperbola. We can just label everything. So this point here is approximately 9.1, -2. This point right here is 6, -2. This is 4, -2. And this is about 0.9, -2. We want to label these things up here. So what are these equations right here? Okay. Well, to find this, we need to know a point and a slope. We can use to find equations of lines. We have this thing right here, m times x minus x1. We need a point and a slope. All of these dotted lines go through the 0.5, -2, so that would be my point. And we just need to know the slopes of these things, and that's what the box here is for. So the slope from here to here is I'm going to rise 4 and run 1. So my slopes are 4/1, or just 4. Okay, for this one. And this one will be the -1. So 4 for this one, -4 for that one. There's my point. So we can go and plug all these in and get these equations. So it'll be y plus 2 is 4 times x minus 5. And we can clean this all up and get an answer. Distribute is -20, and subtract 2 is -22. So y is 4x minus 22 is one of them. And then the other one would be -4 x minus 5. And so then it'll be plus 20 minus 2 would be 18. And so we get this right here, plus 18. So this one right here is y equals 4x minus 22. And this one is y equals -4x plus 18. And if you look at the dotted line, that's about where it's heading. -22 here, positive 18 over there. So there's your hyperbola equations. Okay. And let's look at the next page, which is more in tune of how do I change things and recognize what kind of equations I have. So here's another look at this again, the second degree general equations in this format right here. Okay, there is a discriminant, just like for all quadratics, we have that discriminant, which would be b squared minus 4ac. And from that right there, I can determine what kind of equation or graph I have using the discriminant. You can also kind of tell, as long as there's no bxy term, okay, if there's no term like that, then I can tell very easily what it would be. But if there is one of those in there, then it's going to be a little bit harder to do. Okay, so here is a way to use a discriminant to determine what kind of conic section that it is. Okay, again, remember that as long as b is equal to 0, then the conics are either going to be horizontal or vertical in nature. But when it's not equal to 0, then it's a rotation. So these all rotate. So you can have a parabola going in this direction, where it can open that way at a diagonal, and that gets a lot more complicated. You can also change these things over, use and put them into transformational form or standard form instead of the general equation format. So what is this going to be? Well, I don't see a bxy term, so I can see clearly that that's a positive, that's negative. So we know this one's going to be a hyperbola. Okay, we know this already. We know it's going to be this one. Let's just go ahead and confirm it real quickly. So b is 0, so this will be 0 squared minus 4. A is 4. C is negative 1. And so what we end up with here is a positive 16. So that is greater than 0. So we can see clearly that it's going to be a hyperbola. Okay. I'm going to walk you through again to do the complete the square process to put this into transformational or standard form. So again, remember we talked about this before. We want to group everything together, all the x's together. So we have 4x squared minus 16x. Okay, be careful of signs and all that kind of stuff. So we're going to have minus y squared minus 4y minus 4 equals 0. So we wanted to group the x's together and the y's together. Now, there is no third term over here, and we have this 4 out in front, so we need to take this piece right here. We're going to separate it out from that one over there. And we're going to factor out this common 4 because we can't have a number in front of the x squared to do this. So we're going to have 4. And then in here we'll have x squared minus 4x. And then we're going to add something and then immediately subtract the same thing. And that will take care of the x stuff. For the y, this is where you need to be careful. See how it's a negative y squared? So we want to put a minus here. And by doing so, we're going to put a parenthesis here. And so we factored out the negative. I'm going to take this 4 with it because it's actually part of this. Okay. If you moved it off to the side, well, since that's the pattern you do, let's go and do that. So this is going to be y squared plus 4y. And then we're going to add something and then immediately subtract the same thing. And then here's that minus 4 that we usually move off the constant, we move off to the side. So in these groups, we have to do what? I take half of that number with the sign. So half of negative 4 is negative 2. That's what goes in the parentheses, and we square it. So both of these lines is negative 2 squared. Over here, we do the same thing again. So this over here is positive 4. Half of that is positive 2 squared. So that's what goes over here. The stuff in here, these 3 terms right here become this to be x minus 2 squared. Still a 4 out here. This becomes minus 4. You got to be very careful when you do this. These 3 terms right here become y plus 2 squared, and then this becomes minus 4. So now you want to distribute this through this one because you have the number out here, so you're going to have a 4x minus 2 squared minus 16. Distribute this negative through minus y plus 2 squared plus 4 minus 4 equals 0. So what you notice is that these 2 4s will drop out. Okay. This 16 I'm going to move over there. So now we have 4x minus 2 squared minus y plus 2 squared equals 16. So we have one more step to do, and that's to divide everything by 16. And so we get the final answer of x minus 2 squared over 4 minus y plus 2 squared over 16 equals 1. So there is your hyperbole equation in transformational or standard form. Okay, and we can do that for all the rest of these over here. Just be careful and take your time as you do it, but we can classify them very easily. So I'm looking at this thing right here. There is no b term, so there's 2 squareds. They're both positive but different numbers, so I know that this over here is going to be an ellipse. And I can confirm it by simply doing the discriminant thing. So b squared minus 4, the a number 604, this number 216, and I can see clearly that this, when I multiply this out, will be less than 0. And so when it's less than 0, okay, and either and a does not equal c, I can see that I have an ellipse. Okay, and down here, 2 squareds, they're both the same number. So what's going to happen here is you're going to get a circle. Okay, there's no b, so it's 0 squared minus 4 a c, which is less than 0, and a equals c. Okay, b equals 0 and a equals c. That's what happened. And then this one here, there's only 1 squared. If there's only 1 square, there's only one choice it's going to be, and it's going to be a parabola. Okay? And so, but you can confirm it here, there's no b, so it'll be that minus 4a and c, there is no c, so this is equal to 0. So that's why it's a parabola. So this is a parabola. This over here is a circle. That was an ellipse, and this was a hyperbola. So these other 3 we can do together in class later on outside this video, and I'll show you how to put it into standard form like this on all 3 of those in class time.